This is part 2 in our addition rule and complements video. The general addition rule says the probability of event E or F occurring is equal to the probability of event E plus the probability of event F minus the probability of event E and F. And one way to think about that is we have the two single probabilities added together, but we have to subtract the overlap. So in this case, we consider the idea that not all events are disjoint, are mutually exclusive. So here we have a pair of dice. E is the event that the first die is a 2. That's everything in this second row right here. The event F is the sum of the dice is less than or equal to 5. So there's a whole bunch of sums that are less than or equal to 5. We've got all of these here, these first 4 sums, these first 3 sums here, the first 2 sums here, this sum right here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sums that are less than or equal to 5. But only 4 of them, this one, this one, this one, and this, nope, only 3 of them have 2 as our first die. So if I would just, following the addition rule, I would take 6 outcomes whose 2 is our first die, and I would take, I think, 10 outcomes where my dice is less than or equal to 5, but then I would subtract the overlap. So let's see what that looks like. So I had 6 outcomes where the first die was a 2. I had 10 outcomes where the sum was 5 or less. And then I had 3 outcomes where I had the first one was a 2 and the sum was less than 5. So when I add all those up and subtract the 3 over 36, I end up getting 13 over 36. So we're still adding, the word or still tells us to add, but because they're not mutually exclusive, because I can have some outcomes fit in both categories, I have to subtract the overlap. Now the second idea is called the complement of event. And notice we denote that with a little tiny c. It's like a superscript up there. And all it indicates is the outcomes that are not outcomes in E. So if I was looking at a Venn diagram, E is this circle here. Anything not in E would be considered the complement. Now, interestingly enough, the probability of an event E plus the probability of its complement is equal to 1. So if I know the probability of the circle, all I have to do is subtract that to find the probability of its complement. And that can be very useful. So in this example, 31.6% of American households own a dog. We want to know the probability that a household doesn't own a dog. So I can just take 1 minus the 31.6%, and that's how I know 68.4% of our households own dogs. And notice here, this is shown in decimals rather than percents. I can do something similar here. This is the amount of travel time that it takes to get to work. We're looking for the probability that a resident has to travel 90 or more minutes. So notice that's only one item here. So I take 4,895 and divide that by the total, and I get 0.012. Now, what's the probability that it would have a commute time of less than 90 minutes? Well, I'm not going to add all those numbers up. I'll just take 1 minus the number that I already know. And I get 0.988 or 98.8% probability that I would have less than a 90-minute commute